Hello everyone. So I'm going to talk on the one of the problems that is given for analysis. The problem is, in our day-to-day life, we get a lot of scanned copy of data, soft copies, through email or something like that, and a lot of, if you see a lot of data will be there, which signifies the digits 0 to 9. So if you could see here, and is the task is to how what is the best way to identify those uh, digits depending on the pixel depth. How can you find a pattern and create a model out of it, and also get a good accuracy level of prediction and a good specificity and sensitivity, which basically means less of false negative and less of false positive. So so what we are going to do now, the sample data that is given is one of the test train data, one is test data given. If you see first column is basically the digits, and the rest all columns are which is signifies the pixel depths which correspond to these digits. So we we load the packages required, then we set the path, and then we load the both test and train data, and we check the data sizes, also rows and columns. You could see the train data is 60,000 rows, which is very high actually. It takes a lot of time, if you run any modeling here in so as big data. So the modeling concept that we are going to use here is support vector machine. um, so, and we will check whether data is linear also or is it non-linear, which gives has good accuracy and specificity sensitivity, um, depending on the kernel we use. uh, so here we have checked, also we have a, first column we named it as a digits, and then we checked for NA values and all to, for when we are cleaning and preparing the data. Once that is done, if you see, I have taken a subset of the train data and test data also, because to save time, to make the model creation faster. Then I put the training data, if you could see, using the vanilla.kernel, which is a linear in nature, and to this KSVM method. So this gives me the linear model 1. Then we have what linear model we get, we compare it with that test data, and depending on that, whatever we get out of that, comparing with the test data, and whatever we get from the test sample digits, we compare and see the find a confusion matrix is nothing but it will give you the accuracy level with your prediction and actual data. And you could see here, you got a 90.65 percent accuracy, sensitivity is 82.89 to 98.83, specificity also is good. And if it consider the data is non-linear, considering that we have to try to model from that direction also. So we don't know at this moment whether this data is linear or non-linear. So we use the RVF kernel, and we get a model which we again validate with the test data, and the confusion matrix we get, and this also gives a good accuracy, 94.8. Sensitivity is good at 90%. Specificity is also 98%. So now next step would be to what is the uh, best best option or best model we can get, and for which hyperparameter value we can get a best model, whether it's a linear or a non-linear. So what we do, we use the train method here in this case, and accuracy is our reference here. So we take multiple train control, and then we have different hyperparameters, and using the train method we try to find out in which case of the hyperparams we get a best accuracy. So you could see here accuracy doesn't really change with this different hyperparams, so we'll take it as a see as a point 1. And then we and also confusion matrix wise this looks good, the accuracy and sensitivity doesn't change. If we now for the non-linear case, we take again a few hyperparameters, and we use the train method, and check what are the accuracy we get for different hyperparams. You can see that for hyperparams 2 we get the best accuracy, and also it gives a good sensitivity and specificity. So this looks like RVF will be best fitting for this in this case. and it gives a good accuracy of prediction of the digits. Thank you.